In this video, we're going to take a look at the fifth section of the Python AppSec category on the Veracode Security Labs Community Edition, and this section is on replay attacks. So it's called Replay It Again, and the description says, replay attacks are an easy attack method to forget, but one of the most damaging to the integrity of your application. So we'll click Start here to begin the lab. So we have a little bit of a background here about HTTP requests, and it tells us here that HTTP requests use a predefined format that both the client and server know how to speak, and HTTP requests include several sections. We have the header information, the body content, the URL it's trying to access, and the version of the HTTP protocol to use. And this structure remains the same. It also tells us that because HTTP requests are stateless, each request is isolated, and it's up to the server to persist any data that might be needed between requests. This statelessness and consistent structure make it easy to capture these requests as they go between the client and the server and repeat them as often as desired. When this repeating is used maliciously, it's called a replay attack. So here's the definition of our replay attack. And we have an example here to look at. Imagine a banking application that allows you to make a transfer request via their application. In this request, you would define a to account and an amount value. As we can see here, we have to, and then it has the bank account number, and then we have the amount, which has £1,000 or dollars or whatever, and then the actual HTTP. So here, up here, we have our the URL that it's going to go to, the resource that's being requested. We have the HTTP protocol that's being used. We have some header information, so in this case, a session ID, and then we have our content as well, which is actually going to be posted, the post data. So the server would then process a request and pull the 1,000 from the user's account and transfer it to this account that's been provided. However, if the attacker were able to intercept this using a man-in-the-middle attack, there's nothing to prevent them from resending that same request, and they could update this account number to their own, and they could update this amount to something of their choice as well, and keep resending that request. So that would be the replay attack. And here it's telling us to try and make requests to the transfer endpoint, change the account number to 11111 and see how much you can transfer over. Here's an example request using curl. Alright, let's first of all open up this URL. Just going to take a quick look at it. Here we have a users API. The users API provides information about the users on the system. In order to use this API, you must register and log in. Information on the process is found below. So this tells us a little about the authentication, how to register, what the endpoint is, so we can post to the register URL to register a user, provide the username and the password as post data. Login, similarly, just the same stuff. We pass the username and the password, but instead of passing it to register, we pass it to login. And we can also get all users. So we can return a list of all the users, but we need to be authenticated first of all. It also mentions that a secret value here, and we can see here about the authentication. It's using SHA-256 to make a HMAC and generate, it looks like, a session header and a signature header. So let's go back to our task at hand, which was to try and transfer money using this curl command. So I'm going to paste this in here. I'm going to run that. We're going to see that it transferred successfully, $1,000. Let me go back and modify the account number. And although it's allowing us to go straight on to the next step already, I'm going to update this and just put in ones. And we can try and update the amount as well and say we'll send $100,000. We send that and we get the transfer of $100,000 was successful. We could also do this through our command line outside of this lab terminal, so I can also paste this here, and it'll still, because this URL is just an external URL, which might actually be a bit easier. I'll probably try to work through my OS terminal rather than this terminal here, because it's easier to copy and paste things, and I prefer the format and the color scheme and stuff like that. So we've made the request a few times. Let's move on to the next section. So in this section, we're looking at why the replay attack works. And in the previous step, the example that we went through there, we were able to send through basically numerous transfer requests. We were able to keep replaying that same request and keep moving money from the user's account into ours. If we carried on going on long enough, we'd then end up draining out their account and result with an error to say that no more funds could be removed. So why does this work? If we're not that user, how can we make the request from a completely different place and have the transfer still work? And the key is in the header information, particularly the session ID. So because the session ID was the same, we were able to make that transfer. If I go back through, let me try and actually update the session ID. We'll just go and change this F to an E. And it actually still came through okay. So it doesn't look like the actual session itself was the... Let me go back actually, let me do that again. Okay, I'm going to change the session and say this is not a session ID, and the transfer was successful. Okay, so there's actually a couple of security problems then with this application, mainly that anything can be entered as a session ID and the transfer still goes through. But in an actual, I mean, I guess that's an issue with this lab. In an actual case, we would have needed to use that same session ID, not just any random session ID. It doesn't look like that's actually being checked at all. But okay, we as an attacker, we intercepted the message. We ran a quick test to see if any errors pop up when we did. And this example, no other checks being done related to the request to the session. So we were able to transfer the funds. In fact, no checks have been done at all because it's not even checking the session ID, but oh well. So they note here that the main reason this attack works is the lack of other security controls on the request. In this example where we do the transfer, the only security control that was in place was the session ID value, and the actual value of the session ID is completely irrelevant apparently. So as long as that key is there, essentially, the application assumes that the user's already been authenticated and no security checks need to be done. So this is just reiterating that something like a man-in-the-middle attack, or if you have some way of intercepting requests, you'll be able to replay the requests and you don't need to actually break into the system. All you need to do is sneak in through a hole in the fence. So now we're going to take a look at a more realistic example that's still vulnerable to the replay attack, and that's the user management API. So it says this application will have the same flaw as a transfer endpoint, but it's going to be a little bit more tricky to exploit. And the main code for this is in the app.py, so let's open that up in the editor. So if we just quickly browse through the code, we have a class here, a login class with a post function, and this takes in the username and password. It makes sure that the username exists, and if it does, it's going to go through, this is the session management by the looks of it, so it's going to create a session variable. It's using the SHA-256 library and the OS_urandom variable, or it's pulling a value from OS_urandom. It creates a data object which has a dictionary, essentially, which has a secret value, which is the hex digest of the header, and then a session value, which is the session value, which was just grabbed here, this random value. It's also going to get a hex digest of that, and then it's going to save that. So that will be the session management. So rather than just having, in our example, we just had this value which didn't actually seem to matter. In this case, it looks like it is using some more secure functionality to do that. We have a register function here as well to add a user. You can see that it's hashing a password here, and then we have our users resource, so this will be to get the list of users. We have our transfer there as well. Alright, so all it told us to do was view the code in app.py, so let's move on to the next step and see what it's asking for. Okay, so first it wants us to register a user. It says we need to get more information about the user's API and how to use it, so we can go here and get that information. We have the register endpoint, so we can post to register with the username and password, and that's going to register an account. It tells us that the end goal is to get a list of the current users from the API and their details from the user's endpoint. So this is going to be our end goal, but we need to be authenticated in order to do that. So to start, it's asking us to register a user using a tool of your choice. So we can use curl, or we can use Python request library. Here in the example they've used curl, so they're making a post request. As the post data, they're submitting the username and the password, and then they have a header set to say that the origin is this Veracode site, so it's checking to make sure that it's not just being redirected from like Facebook or something like that, and then the actual URL that we're trying to visit, the endpoint. So we register this, we should get a successful response with a message about test user 2 being registered. So we could do this with curl. In fact, let me copy this and we'll do that first. So we'll set up a curl, we've successfully registered test user 2, but I'm also going to set up a Python script and do some of this with the request module as they mentioned there. So let's do codium replay.py, and then we're going to want to import the requests module. We're going to want to define some variables as well. So our URL is right here. Let's get a copy of that. We want some login creds. So what credentials are we going to set up? I'm going to, oops, I didn't mean to press whatever I just pressed. So we want a username. I'm going to set that as crypto. And then we want a password, which I'll also set as crypto. We're also going to have some headers. So at the moment we know that we need the origin header, so I'm going to say headers is equal to, we'll just create another dictionary. We can add more to this dictionary later as we need, but let's just grab this origin header. And that looks good. And we can start to build this up then. So first of all, we want to do register. Let's say response is equal to requests dot, and it's a post request we're making. So you can see a post, we want to pass in the URL, we can pass in data, we can pass in JSON, we can pass in our headers and things here as well. I'm going to do request.post, and then we want to go to that URL up above, but we also want to append register to it because we're trying to register in this case. And then we can also say our data is equal to login creds, because our data is going to be the username equals our username and password equals our password, and that's exactly what we have here. Username equals username, password equals password. So we'll send in login creds as data, and then we can also send in our headers as just the headers that we have above. That should get us a response back. So we can, whatever we want to access here, I'm going to say response.json. Let's import JSON as well. Just to make this a little bit easier to read, I'm going to do json.loads and then response dot. Let me just show that here. If we go to response dot, we can access the cookies, we can access the headers, the response headers and things like that. The status code, we might want to see if it's 200 OK or if it was unauthorized or something like that. We can access the URL. In this case, we want to just get response.text, and then I'm just going to print out response.text. Pretty print, just it can format. Sorry, response.json. We're gonna response.json. We're gonna print out. Pretty print can just print out JSON sometimes in a nicer format, or dictionaries and things like that. So that looks pretty good to me. Let's test it out. Run Python replay. We'll get pprint is not defined. Okay. I'm going to import the Pwn Tools library here. There we go. I didn't realize that the pretty print came from Pwn Tools. I'm so used to just importing Pwn Tools in every Python script because there's a lot of other useful functions in there as well related to like hashing and stuff and converting stuff between hex and otherwise. You have, I can't remember the encode. I can't remember exactly the way to hash here, but it can make certain functions a bit easier anyway. Alright, so that's all good. We sent that off, we got back user must be unique, success false. So let me change this to crypto123, just make sure it's all working. We run it again, we get user successfully registered, success true. Alright, cool. So let's go back here and see what it wants us to do. It wants us to log in. Now that we have a user in the system, we can authenticate by sending this to the login endpoint. And here all the details are the same, so we're sending all the exact same details that we sent right here, we're just sending them to a different endpoint. And it's going to give us back a secret and a session in response. So let's do that. I'll comment this out just because, actually I should have copied it first. I'll comment it out just because we've already registered and we don't want to get that alert every time saying that that the user already exists. We'll do that now. Python replay. We run that and we get back our secret and our session tokens. So let's go back and see what it's asking for now. I don't think it wants anything else off us, it just wants us to go into the next step. Okay, so now that we're able to log into the API, we want to try and get this list of users. And as the documentation shows, it says we'll need our session and our secret values, which have been returned to us right here. And this value is used to generate a SHA-256 hash signature that's sent along with the request as the X signature value along with the session ID. Here's a Python script that shows how it works. Copy this into a file. Okay, so let's have a look and see what's going on. They have a session and a secret variable that's been set up here. And they're creating a digest where they're making a HMAC from the secret, so the secret value that we get back right here. They're going to hash that and the data, so whatever post data you're sending. In this case, this is a GET request. We're not sending any post data. This is going to be empty. And it's going to make a SHA-256 get the digest of it. So that's our digest. That digest is going to be sent as the X signature, as the value for the X signature header, and then the X session header is going to get the session value, which is just right here as well. So let's go. It says we'll need to make a login request, get our session and our secret values, plug these into the script, and then use them along with that. And we've already done that. But let's try and automate some of this as well. Let's go back to. I'm going to take a copy of this. That's the only thing I'm going to bother copying. We also need to import hashlib and hmax, so let's do that. Okay, so I'm just going to put these on one line. We've got JSON, we've got our hmac, and we have hashlib. Save that. Oh, it just it automatically done that. I was wondering why that. I thought I'd put them all on one line. Okay, that's fine. Whatever Codium wants to do with it. So we have our digest right here. What I'm going to do is I'm going to create a new function. I'm going to call it gen signature, and let's return this digest that it's going to create. And it needs the secret and the data of us here. So we're going to pass these in as parameters. Let's make this reusable. So we'll set secret and data. And then we're going to perform our login first of all. But once we've performed our login, we've got this response.json. We also want to say then, let's go back to our command line. So this is inside a message object. And then inside that message object, we have a secret and a session. So we'll say that our secret is equal to the response JSON in the message object, and then we want the secret. And then we're just going to say exactly the same for our session as well. Just update the values. Session. Okay, it looks good. So we log in, we capture our secret and our session values, and then we want to generate a signature. We'll say our signature is equal to generate signature and pass in secret and data we want to pass in, which is just going to be empty in this case. So I'll just put in just some quotes, and then we need to update our headers. So we have our headers here. This is set in. We already have the origin header set, so we want to set an X session header, and we want to set an X signature header as well with the session and the digest. So let's say we've already got our headers dictionary up here, so we'll just add in a value to it. We'll say headers, was it X session, is equal to that's equal to our session variable that we've grabbed right here, and then I'm going to copy that, update it with X signature, and then in there we'll just put in our signature, which we've generated using secret and data, which in this case is empty. So we've returned those, and then all it's doing is it's basically making a request to the URL, which in this case is users, because we want to retrieve the users, and it's applying the headers which contain the origin, the X session, and the X signature. So these are all used for the session management. Obviously, if this data was to contain different variables, if this was being used, for example, for the login and the username and the password were being sent there, it would produce totally different results. But because the username and the password might be known by the attacker, it still wouldn't be too hard for the attacker necessarily to replay this attack. There needs to be something being used to perform this hash function that's not determinable by the attacker can't guess, can't capture, or can't otherwise determine. So I think that's right. Let's go and make a GET request this time then. We'll say response is equal to requests.get, and then we'll pass in the URL plus users. We don't have any post data to send because it's not a post request. Don't have any data to send at all, so just set that to headers, and then we'll print this out. Let's copy this and print that. So we've already registered a user, no need to do that part. Let's try and run Python replay again. And you'll see that, yep, it generates our secret and session. We then send the secret and session along with our next request, and it actually retrieves all the users in the database along with their hashed passwords as well. So we can potentially go and start looking at cracking those now as well. One thing I'll typically do whenever I see something like this is go and check the hashcat example hashes list. This is essentially just what you get from running the hashcat help menu, but it gives us the list of all the different modes and the different hash types that are associated with those, as well as an example. So I can go here and look for, okay, I can't find 2B, but if I look for $2, we'll see bcrypt, $2, blowfish, and then we have an example which looks very similar to ours. Instead of 2B, they've got 2A, and it's followed by this. And if we go to our actual code editor, we'll see that where's the register user function? That's login. So we have the register, and you can see here that, yeah, it uses bcrypt. It's hashing the password along with assault as well. But now that we've got that, we could go and start trying to brute force this with hashcat. It's a bit outside the scope for this challenge, so let's move on. We'll see, is it asking us for anything else here? And so here it's explaining that even though the SHA-256 is used and the hashing is done, there's nothing, if the input is the same, that's not an issue. So essentially, if this request was intercepted just like the other requests, it could be replayed. It wouldn't be as easy for the attacker to modify that. So for example, if it was a post request where we were sending something to $1,000 to whatever account number, if that had been hashed and the attacker didn't know what was in there, then it wouldn't be easy for them to just go and say, I'm going to change that account number, I'm going to change that amount to something of my choice, unless they knew how the hashing was done, in which case they might be able to do the same thing anyway. So in this case, it mentions we were looking at a GET request, but POST requests can also be done. Even with a signature check like this, the same attack is possible. There's nothing changing the request, so the attacker could, oh, okay, so actually the hash value isn't updated at all between the requests. I was under the impression that each time a request was made, it would hash this data, but I guess if the data is always blank, that wouldn't work the same. Okay. So what they mention here now is that we can try to prevent attacks like this by adding in some randomness. So that's what I've mentioned before. There needs to be something which is not determinable. It can't be guessed. It can't be captured by the attacker and used to craft their own attacks or just replay the same requests. So let's move on to the next section where we'll be looking at introducing randomness. So it suggests that an easy way for us to implement some kind of randomness is to use the current time. So it's constantly changing value, it's never the same twice. If you use the Unix epoch, which is basically the value since something 1970 or something like that, and in most languages this can be defined down to the micro or milliseconds. So we can use this value to introduce some randomness that the attacker is not just going to be able to guess, and we can also use this to reduce the amount of time that the request is valid for, not just make it difficult to reproduce. So we can add in a couple of different security features based on this one parameter. So what do we need to do to our code? It says here we need to update both the server and the client to inject this value into the hash creation and validation. So we need to open up app.py, locate the users class where the user endpoint request is handled, and it says currently the code pulls the data from request and uses the secret provided to regenerate the hash for verification. So let's go and make some of these changes then. We're in our code editor right now. We need to import time. Let's go and do that. And let's go down to our users section and let's see what the difference is here. So right here we've got data is equal to request.data. We calculate the secret, which is user secret encode UTF-8, and then we get our digest. So the digest is calculated using the secret value, which we've already been assigned, and the data value, which in our example previously was empty. So what they're asking us to do here, we already have our data is equal to request.data, so we also want to calculate our milliseconds. It's going to get the time in milliseconds, and then our secret, instead of just encoding the secret, we're going to encode secret plus the time in milliseconds. So we'll replace this here, and we've just added on the millisecond time encode into that secret, and then we just perform our hash digest as usual. So that's just what it's explaining there. We're using an epoch time in seconds, well, in milliseconds, to make sure that it's more randomized. The resulting signature would mean it's different every time, preventing a direct replay of the request. So every time the request is generated, it will be based on that current time. So we could say that if the server receives a request and the time, the milliseconds on it was greater than 100 or something like that, then it's a replay attack. It could also be used to try and actually identify attackers from that are trying to do replay attacks. So this solves the problem of randomness in a request, but does it solve the replay attacks completely? Unfortunately, no. So let's go into the next section and find out why. So they mention here that while we've made some improvements, there are still problems. One of the problems is that we're locking it down to a 1 second limit, so an attacker could use a script, kind of like we've done here, to automate this, and it could send a lot of requests within 1 second. So we could try and say, alright, well, we're only looking for milliseconds, but then we're going to have issues with network latency. So in some cases it might be a legitimate user, but based on their connection to the actual server, it might take more than a few milliseconds. So what else can we do? Fortunately, there are other controls that can be put in place to prevent these kind of attacks, and than just adding in this randomness. So it gives some examples here. Let's go back to our money transfer example. When a legitimate user makes a request, you can gather information such as the amount of the transfer, the account transfer to and from, and the IP address. So this would be a possible option. If you were using the IP address to also manage the session, you could, even if an attacker got everything else right and it was the right amount of milliseconds and they got the secret and everything was hashed correctly, if they replay that attack but they're doing it from a different IP address and the IP address is being taken into consideration, then it might be rejected for that reason. And ultimately it says that no solution is perfect. A determined attacker will almost always find a way around whatever controls you have in place. That's why the multi-layered approach, or defense in depth, is favorable over a single control. So this is kind of a balance as well, right? Because defense in depth is important. If you have multiple layers of defense, then if one of them fails, if one of them is breached, you still have other layers of security. An issue can occur though if you add too much complexity to the security of a system. So we saw in another example, I can't remember which lab it was, how a two-factor authentication style system had been set up, but due to the way it had been implemented, it actually allowed us to bypass earlier security checks. So sometimes adding additional layers of security, I mean, ultimately is a good idea, but if it's not done properly, it can actually undermine the existing security measures. So that's something worth bearing in mind. And here, yeah, this is the defense in depth approach. So we finish this lab, we can get our credit and move on to the final lab in this category, which is key flaws in JSON Web Tokens. So we'll move on to that now.